Welcome to another Build Day TV episode. I'm Alistair Cook, and we are carrying on our series looking at the VMware SD-WAN solution. Naturally, we need an expert, and we have with us Rohan Naggi joining us again. Hi, Rohan. How are you doing today?
Hey, Alistair, I'm doing good.
Great. So in the last episode, we deployed a bunch of the edge appliances. So one in the Sydney region on AWS, one physically with Jeffrey, who is hard at work as usual, making us look good. And you've got a couple more as well. So what we're going to do is join those together today. I'm going to turn them into an actual WAN for ourselves.
Yes. So last episode, we activated the edge device, my home edge device, Jeff home edge device. I have AWS instance up and running in US East region. You have a New Zealand region, AWS edge up and running. Now, when the edges are up and running like branches or data center, we need data path between them. We need to build up overlay, SD-WAN overlay tunnels between them so that user traffic, or if I want to access some application which is sitting behind data center or somewhere in the cloud, then we should be able to access those applications in a secured and an optimized way. And that's where SD-WAN magic will come to play. And that's what we'll do it in episode 4, where if there is a blackout condition, brownout condition, those things will check it out. But this episode is dedicated on building up those paths. That's where Cloud VPN and routing comes to play. And here we are going to execute many tasks out here because there are many different topologies supported. If customer wants to have hub spoke topology where they have their workloads sitting in the data center and they want to access them from their branches, so branch to hub, branch to data center, that's where we'll be covering task 1, task 2, then we'll be building a branch to branch VPN so that two branches can talk to each other, either using gateway or hub side, or maybe dynamic branch to branch. And then task 7 and 8 is dedicated for routing. When you have neighbor routers on your edge, let's say on your LAN side, if you're running Ospf or BGP, how do you form neighbor relationship? All those subnets which are underlay on your LAN side, how they get to the overlay. So those kind of traditional routing protocol support and intercommunication between overlay and underlay, we are going to talk on those two routing tasks there.
So that's an awful lot of things to build, and that would be quite a lot of work to do with a conventional WAN solution. It's going to be interesting to see how long it takes us to do these things with a software-defined WAN.
Yeah, actually, it's not going to take weeks and weeks here. We would be able to cover everything, and that's like a enterprise customer, when they get the edge devices, this is what they do on day 1. Once it's activated, they have to build up topologies. And good thing with SD-WAN is that you can have multiple topologies supported. You can have hub and spoke topology at the same time, branch to branch. So you can have multiple topologies in a single enterprise network. Let's understand the Cloud VPN feature. So with VMware SD-WAN, overlays can be built over any network, whether it's public internet or private internet like MPLS and more. So by default, when your edge device gets activated, it will create an SD-WAN overlay tunnel to VMware SD-WAN gateways. If you remember, gateways are managed and hosted by VMware SD-WAN. So that's kind of a controlled SD-WAN overlay tunnel, which can do bandwidth measurement, auto discovery, all those things. Once you designate an edge device, let's say in a data center as hub device, then all the edge devices, your branch side will form an SD-WAN overlay tunnel, a static end-to-end SD-WAN overlay tunnel to that hub site. And that's secured. That's an end-to-end static overlay tunnel. And these overlay tunnel for VMware SD-WAN, they work on UDP port 2426. So in case you want to build branch-to-branch VPN, SD-WAN overlay tunnel, then for, let's say, this is branch 1, this is branch 2, then to initiate that SD-WAN overlay tunnel for that branch 2 to accept that traffic, you need to open up UDP 2426 port if you have a firewall running. So let's talk about what are different ways the edges can connect to the Cloud VPN. And remember, with Cloud VPN, with VMware SD-WAN, it's a simple click and you can enable Cloud VPN. And then you can have hub and spoke topology, branch to branch, dynamic branch to branch, or even building up a secure VPN tunnel to a non-SD-WAN site, or let's say to cloud. So with edges, the first one is meet at the gateway. That's what happens on day one when the edge device gets activated. When the edge device role changes from edge to hub, when the edge device is nominated as a hub, that's where end-to-end static overlay tunnel, SD-WAN overlay tunnel, is built up from the branch edge device all the way to the hub site. And then the third option is you could also have branch-to-branch communication using hub, where you hairpin the traffic to the hub or the gateway, or have a dynamic branch-to-branch communication out there.
Designating as a hub is just administratively, I say use this particular device as a hub. It's not that there's a different device I have to buy or anything like that, is that?
No. You don't have to buy a different device. It's the same edge device, which you plug in and you change the role to the hub. So the moment you change the role to the hub, all the edges, when they get that IP address or that information about a hub from the orchestrator, they will just build up an SD-WAN overlay tunnel to the hub. So this is where that tunnel initiation happens. The step one is all the edge devices, which are, let's say, at your branch site, they will receive a list of VMware SD-WAN gateways, IP address, and from the orchestrator. So from the orchestrator, they will receive the IP address once the branch edge device gets activated on that day one, and then they will build up an SD-WAN overlay tunnel, like a control plane, SD-WAN overlay tunnel to the gateway. That's where the measurement of the WAN link happens. IP auto discovery of the service provider IP address, the upload and the download speed. All those bandwidth measurement happens on day one as kind of a step one. And then when the edge device role changes, let's say on a data center site, you change the role to the hub. That's where that IP address kind of goes to the gateway. Gateway knows all the IP addresses for the hub. And that's where orchestrator will send out those information to the branch site, to the edge device. And now the edge device knows that I need to initiate an end-to-end static overlay tunnel to the hub site. And that's where these edge devices will build up an SD-WAN overlay tunnel over the public internet, over the private MPLS. They will build up that end-to-end tunnels.
One of the things I picked up in there was that the tunnels, we've got redundant links. Those overlay tunnels are stood up the whole time, even if maybe we've got traffic active on only one, so that if we've got it configured for failover, it doesn't have to stand up the link and validate that link at failover. It's stood up the whole time, which is much better for the performance of that failover if it has to occur.
Yeah, so if for subsequent failover needs to happen, then these tunnels needs to be up all the time. Otherwise, when one link or one, if underlying WAN infrastructure changes because of blackout condition or brownout condition, then it takes time to initiate or, trigger a second SD-WAN overlay tunnel. And that would take time. And, for a real-time traffic, that would be a big problem out there. And if you see out here with VMware SD-WAN, it's not that on day zero, you build a point-to-point tunnel to every other branch in your network. It's not like that. It's only for the hub site. And based on the profile, actually, you can do that, So you can create multiple profiles and you can say, I'm having a West Coast profile where branch 1 to branch 50, let's say all the branches which are there in West Coast will form an SD-WAN overlay tunnel to this hub 1, which is in West Coast. And then on East Coast, branches will connect to the East Coast hub device also. So now that we have understood this Cloud VPN, simple click with Cloud VPN, you can have multiple topologies. Let's execute these. Let's understand how these really work out. So task one is that's what we are going to perform out here. So before we perform the task, what I really want to show is day one when the edge device comes up online, they initiate an SD-WAN overlay tunnel to the gateway for that auto discovery of IP addresses for the WAN circuit, for the service provider, and the upload and the download speed on that WAN link. Okay, so now that we are logged in, if you remember, we have my home edge, which is this edge 6x0, and then we have Jeff's edge. We have an edge in East Coast region on AWS. We have the New Zealand edge out here. So what we are going to do is, for my home edge, I'll make this as a branch edge device, which will be talking to a hub device. So I'm going to change the role of this AWS edge to an hub device. Once that happens, then this branch edge will be able to kind of form that hub and spoke topology. But before that, what I really want to show is when the edge device gets activated, we can check that there are SD-WAN overlay tunnels built up to the gateway, those control plane traffic. So in this case, we have two gateways. One is primary gateway and secondary gateway. And at the same time, for this topology for my home edge device, I have two WAN circuits. So it means on a single WAN link, I'll be connecting to two gateways. So let me click on run here. And you can see here, I have Comcast cable and Sail Internet out here, two service providers. And it has formed SD-WAN overlay tunnels to each of the gateways here. Gateway 1, which is 133, and then the gateway 2. So what is happening out here? From my home edge device, I have two ISPs, and then we have primary gateway, and then I have a secondary gateway. So we'll form an SD-WAN overlay tunnel, let's say on link 1, change the color out here, and then we'll also form an overlay tunnel to the secondary gateway. But all the traffic will go on the go through the primary gateway. They will go off through the primary gateway. The tunnel will always be on through the secondary gateway out here, but all the user traffic will always be on the primary tunnel. Same goes with the second link. We'll form two tunnels out there to the primary gateway, and then the second tunnel to the secondary gateway out here. So let me go back to the orchestrator out here, and let's do that configuration. So we'll do that configuration from the profile. So you can see here, I have two profiles, branch home edge profile and the data center profile. So right now, my AWS edge device, you can see here, AWS edge device is also part of the branch profile. So I'm going to move this to a data center profile. So let's do that quickly here. Why? Because I want to make that AWS edge device a hub device, because I have some application servers which are sitting behind that AWS edge device, so that my laptop, which is connected to my home edge device, like a client, can access those application servers. In this case, I'm maybe running a VNC server on that AWS edge device. So we have this internet. We have this AWS edge device. AWS edge device. I have my home edge device, and my laptop is here. I have two internet connections. One is service provider 1, ISP 1, and ISP 2. I have one internet connection out here, and then I have a Windows server and a Linux server sitting out here, which are on 10.0.4.x subnet. Once we enable hub and spoke topology, once I change the role to the hub here, then I should be able to, from my laptop, I should be able to access these resources. So I'm running VNC server on one of the application servers. What we have done is we have moved this edge device, AWS edge device, to the data center profile. Now what I'm going to do is I'll go back to the profile, home edge profile, where my home edge device is. I will go to devices, And the only thing I'll do is I'll enable Cloud VPN, and we'll see simple steps. So it's already enabled by default. So I want to have hub and spoke topology. And you can see here, we have different options out here. And like I mentioned, you can have hub and spoke topology, you can have branch to branch, you can have multiple topologies at the same time. So I'm going to enable branch to hub. This is where I will change the role of one of the edge device, in this case, the edge device, which is on AWS. I'm just going to move it to the hub. I'm going to click on OK, and I'll save these changes, and that's where the hub and spoke topology will start getting initiated. We can go and check under Events tab what is happening out there, so we know what are the events which are happening. Remember, there are keep alive messages which are sent every 30 seconds from the edge device all the way to the orchestrator. And then in response, orchestrator will send out the response if there are any new configurations. So it takes 30 seconds for all the configuration to get pushed from the orchestrator to all the edge devices. And you can change the timer, but I would not advise to change that timer. So let's kind of wait for 30 seconds, and you can see once the configuration is applied, then we can go and check first from the orchestrator remote diagnostic tools that now there is an end-to-end overlay tunnel from the edge device to the hub device also. And those gateway tunnels are always going to be there. So now we have more tunnels to the hub side. So from branches, we'll have tunnels to the gateway and then to the hub.
And you typically use the hub because there's a data center where this device is that has a lot of resources that the branch is going to access.
Correct.
Whereas if I was going to use the gateway to do all of that Cloud VPN, that's more where the branches need to talk to one another rather than talking to a central location.
Yes. Yeah. So you can see here, the configuration has been applied to my home edge device. So the first thing we'll do is we'll go to test and troubleshoot. Again, remember, there is no CLI out here. So you can use the single orchestrator, the management orchestrator, to check all the configurations out here. So now you see a difference out here when you see list path. Earlier, before we did this, there was only gateway. Now we see a hub device. So I'm going to click on run out here, and you will see that this edge device, my home edge device, has formed a secure SD-WAN overlay tunnel all the way to the hub site out here. And it gives out all the information, the state information, what's the bandwidth, latency, jitter, packet loss, all those information is kind of given out here. So you have done that validation from the orchestrator. The second validation is from the user point of view, where I should be able to access those application servers which are sitting behind the data center, in this case, that hub device. So I have a VNC server running on 10.0.4.122. This is the workload which is on my AWS account where this hub device is. So from this laptop, I will do IP config. So you can see here, 20.22 is my laptop address. This is where my laptop is connected to the home edge device. So the first thing I will do is let me try out a ping, whether that ping works to the data center device or not. So I think I have the correct IP address. Let's check it out. Yeah, so you can see here, I have the ping working all the way from the branch to the data center. So from the laptop, I'm talking to the VNC server, which is on the AWS site. Now, the second thing is now we can access the application. So I'm going to open up a VNC to that hub site where these application servers are. I'm going to type in my password, and this is where I'm accessing the Windows server, which is running the VNC application, the VNC server, and you can see that Windows server IP address is what I mentioned, 10.04.122. So that's kind of a hub and spoke topology, which we have kind of created for this lab task. So you can see here, we have done this hub and spoke topology. Branches can talk to the hub site.
That's branches to central data center, and that would be a really common use case at the moment for work from home to access resources in the data center that you'd otherwise have accessed across the local network if you're in the office.
Yes. So you're backhauling all the traffic to the data center because you have enterprise servers, application servers sitting out there, or maybe because of the compliance reason. So let's perform next task where we do branch to branch using gateway. My home edge device will be branch 1. I'm going to change the role out here for this AWS edge device from the hub to a branch 2. So if I have to do this, it's a simple. I will just move this edge device to a different profile. And that's where we can do branch to branch communication. Let's go back to our configuration. So what we are doing out here is we want to showcase branch to branch using gateway. So branch 1 can talk to branch 2 through the gateway. So we are not going all the way to the hub site out here. So I can keep this enabled, but let me disable this just for this specific scenario. So I'm going to enable branch to branch VPN is enabled. I'm going to uncheck this dynamic branch to branch. And here I have an option. So I can either use cloud gateways or hub for branch to branch communication. Our use case is branch to branch using gateway, and that's what I'm going to do. So I'm going to click on save changes here. Again, 30 seconds for the keep alive message. And then once the orchestrator pushes all the configuration to the edge device, then we'll have, we can execute that task. So you can see here, edge to edge VPN is enabled. Once we get that message in the event log that configuration has been applied, then we can try out branch to branch VPN. So
and we're doing branch to branch through gateway to minimize latency, to avoid hairpinning back through a hub. But if you could do branch to branch through hub, if you needed more visibility at that hub.
Yes. So if you have a hub device, you have branch 1, you have branch 2. If you want to have communication, yes, you can hairpin all the traffic through the hub, and branch 1 can talk to branch 2. Or in this case, we have our gateways, like I mentioned, these are deployed, these are strategically placed, they are closer to all these SaaS providers. So you can have similar functionality to reduce the latency so that the branch 1 can talk to branch 2. So that's a second scenario. The third scenario would be where you could enable dynamic branch to branch between branch 1 and branch 2. And this tunnel is dynamic in nature. It's on demand. But these two tunnels are not on demand. These are static. They are always on. That's the difference out here. So in this use case, what we are doing is my home edge device, which is, let's say, 610 edge device. That's where my laptop, I have 2 internet links. Let's say this is the internet cloud out here. And then my branch 2, which is on AWS. This is where it is. We have a VNC server out here, VNC and the other application servers I have out here, which are on subnet 4.x, 4.122 in this case. So we will do branch to branch VPN using the gateways out. Let's do that out here. Let me click on refresh to see if there are new events out here. Yes, you can see here the configuration has been applied. So it means my branch to branch VPN using gateway is enabled. Let's quickly first validate using the orchestrator out here. And we have a VPN test, a simple click we can do, and we can leverage that tool to check that out. So you can see here, now you don't have that hub device out here. So we have a list path. It will show the path from my home edge device to the gateway, to the primary gateway and to the secondary gateway. And then we have a tool called as VPN test. Let me click on that, VPN test. I'm going to click on run. And this is where it will show all those VPN paths which are established between my home edge device to the other edge devices out there. So let me quickly run this out here. so that the branch-to-branch VPN can get established out there. You can see here it's still showing me fail. I think it will get enabled.
So it seems to have succeeded to Jeff's home device, but not to the AWS Edge. Was there something else that needed to change on there to make it work?
Yes. So if you remember, we were using in the last use case, we were using this edge device. We changed the role to the hub. And at the same time, this edge device was part of a data center profile, a different profile. So what we need to go do is we need to go back and we need to go to the profiles. And you will see out here, actually, let me show you. So this is my home edge device, which is part of the profile, which is an expected profile out here for me, which is a branch home edge profile. But if you see this AWS Edge, it's part of a different profile. And this is where branch-to-branch VPN is not configured. And let me show you that actually, so you will understand, because this can happen in a real-world scenario also, that your edge devices are part of different profiles and the configuration doesn't match. So you can see here, the AWS Edge, only the Cloud VPN is enabled, but we haven't enabled branch-to-branch VPN. So for me, an option one would be to enable branch-to-branch VPN out here and have the, if the gateway is common between these two branches, we can have branch-to-branch VPN between different profiles. But what I'm going to do here for simplicity, for understanding the concept for the audience, is I'm going to move this AWS Edge device to the same profile where my home edge device is. That's what I'm going to do. So let's do that. And after this, when we run the VPN test, you will see a pass for both the edge devices out here. So let me go back to the monitor page out here.
But we could have just enabled branch to branch, whilst for some uses the device that's in your AWS Edge, that could be a hub device for some connections and take part in branch to branch for other connections.
Yes, I could have done that. So I could have enabled, option one would have been, like I mentioned, in the data center profile, I would have just enabled branch to branch VPN. I could have done that. But option two, what I've done is I have moved that edge device out of that data center profile, because I know it's not going to be a hub device in the near future. So it's going to be a regular branch. So I just want to move it to the correct profile.
Really importantly, although we're making these changes after we activated these edge devices, normally this policy would be set up, this profile will be set up beforehand and applied to the device as it's activated. There wouldn't be an additional activity here.
So on day one, when we dropship that edge device, when you create a site, that's where you mention that this edge device will be part of this data center profile or my East Coast branch profile, or this particular profile. So that's where you set it up. But then you can change it based on your setup also. So you can see here all the events out here for the AWS Edge device. Let's quickly go to Test and Troubleshoot tool. Let me click on my home edge device, and we will do that VPN test again to check that has it formed that from branch one, which is my home edge device, to the gateway, and then the other branch, which is the AWS Edge device. So let's quickly test all the VPN connectivity, and you can see now, Alistair, here that my home edge device has that connectivity to the AWS Edge device. You can see the pass result out here. So that's the validation we have done from the orchestrator. Now let me show you through a trace route that my next hop from my edge device here, my next hop when the packet goes from the LAN to WAN should be this edge, should be this gateway before I reach out to this branch 2. The next hop should be the gateway. Let's quickly check the IP addresses for the gateway so that we can validate when we do the test out there. And I can run a trace route from my orchestrator out here also, but we'll do it from the LAN side of it. 133, you can see here the gateway, and 112, That's the second gateway. Let's first try out ping, whether the ping works or not. So the ping works from my laptop, which is the client machine, to the AWS servers, where the servers are application servers are setting out here. So let's run the trace route. So this is where it should show me next hop as one of the gateway IP addresses. So this is the LAN side gateway on my home edge device.
I was looking at the latency for those pings, and there seemed to be just marginally higher latency when we're going through the gateway. It didn't seem like it was a huge amount of difference in the latency going through the gateway versus going direct to the hub.
Yes. And at the same time, what I can do is once this trace route is happening, I can also showcase you that we can access the application, because that's the end goal, right? The end goal here is that I should be able to access the resources which are sitting on that other branch out there. So you can see here, I can access that application out here.
Yeah.
So you can see here, the next hop from my home edge device, so my subnet is 20.1 out here. It is going through this gateway .133. That's the next hop. So branch to branch communication is happening through the gateway. So let's go to the next task out here. So in this case, my home edge device has two service providers, ISP1 and ISP2. So what I'm going to do is, from my laptop, when the connection is going out to that application server, in this case 10.04.122, where the VNC server is out here, if one of the link goes down, you will see that I'm still with uninterruption, I'm still able to access that application out here. And that's where that application performance, DMP or dynamic multipath optimization comes to play. There is no wait time. It's not that my connection to the application server will go down and then it will take some time to initiate it. That's not going to happen, because tunnels are always on in this case. And for that, I'll be pulling out a cable from one of the service provider connection. So let me just copy paste this, open up multiple windows out here so that we can check the transition out here. So I can put my edge device in what you call a live mode, and that's the live mode. Many customer support engineers use it on a daily basis to troubleshoot scenarios. If I want to find out where my application traffic is going through, which link is being utilized, you can use these live troubleshooting, which is on this transport tab. So what I'm going to do out here is I will start the live monitoring, and this is where you can get the TCP UDP level details also. So you can see here, I have put it in the live mode out here, and I can initiate a ping also at the same time. So let me close this trace route. Here, when you go to the live mode, it will show you which link is being used for the ping, for ICMP. So let's see that.
So I think I want to highlight this live mode again, because you've used this quite a lot of the way through whenever we've been doing troubleshooting, was not waiting for that 30-second cycle time of heartbeat back from the portal to the edge device, that this is establishing a connection that's in real time and monitoring what's going on a single device from that central console. I think that's really cool. And you've used this whenever we've done any troubleshooting, we've gone into this live mode.
And we will be using for other use cases also. And trust me, a lot of my customer support engineers, even customers, they use these live mode when they have to do troubleshoot. They tell us that, it's just at a single orchestrator, single management station, we are able to access so many tools and resources, whether it's at the link level or at the application level. All those statistics, all that information is kind of displayed out here. We don't have to log into multiple VMs or multiple stations.
Multiple consoles and trying to coordinate.
Yes, there's no CLI out here. So you can see here, I have two service providers. You can see that ping from my laptop, and this 10 subnet is the application server, which is running VNC right now. So I'm doing a ping there, ICMP reach. So what we are showcasing out here is branch to branch communication is happening right now. It's using this underlay, this Comcast cable service provider. So the moment this blackout condition happens, or there's a brownout condition which happens, and that kind of goes below certain application SLA, that's where in a sub-second fashion, there'll be a link steering happening and will use the other service provider link out here. But in this case, what we are going to do is we will do a blackout condition where we'll pull out a cable from Comcast link, and that's what I will be doing it from my home edge device. I'll pull out the Comcast cable, and you will see that this ICMP traffic moves quickly over in a sub-second over to the service provider too.
Oh, switch over.
So you can see here the Comcast blackout condition happened, and we still have the connectivity. We still have the Zoom call. That's a real-time
Can
traffic.
you pop into the ping as well? And we should just do one ping that was a little bit longer before it scrolls away.
Yeah, so you can see here.
We've got a switch in time because we're using a different link.
Yeah, so ping is still working, and my VNC session is kind of still on here. You can see here. We are doing this task number 3, branch to branch in a blackout condition. So if you have multiple WAN circuits, so if the traffic was going through one of the link, we did a sub-second, the system did a sub-second failover to the other link, and that's where we still had the connectivity between branch 1 and branch 2 out there. So let me quickly go back and bring in that connectivity back to this Comcast cable. And at the same time, what we need to remember is our Zoom traffic was still intact. There was no audio or video.
I was impressed that there wasn't even a very long ping time in there. I was expecting a sort of 300, 400 millisecond ping at switchover, and it wasn't. It just went from 83, 84 to 120 and was stable at the 120.
Yes. I'm back out here. So you can see here, the edge device has detected that the service provider link is back online, and the ping has moved out here. Let's move out to the other test case out here, which is the dynamic branch to branch VPN. So this is the only test case where when you have branch 1 edge device and branch 2 edge device, and you have internet in between. When you see an interesting traffic between branch 1 and branch 2, so let's say the subnet here is 10.x, the subnet here is 192.x. This is where my laptop is, and the moment this edge device sees that there is an interesting traffic to branch 2 and dynamic branch to branch is enabled, this is where that dynamic on-demand SD-WAN overlay tunnel will be built up between the branch 1 and branch 2, as opposed to branch using gateway or a hub and spoke topology where there is a static VPN, static SD-WAN overlay tunnel always on. So in this case, we'll check out the SD-WAN overlay tunnel, which is in dynamic way. So what we are going to do here is we will go back to the configuration profiles, home edge profile. This is where our profile is, and the only thing we need to do is enable dynamic branch to branch. So I will go here, and the only thing I need to do here is enable branch to branch. And this is where that, if you remember that slide deck where we talk about the profile isolation that comes to play. So right now I'm just enabling to all the edges. If you want profile isolation, you could have selected this option out here to edges within that profile. So I'm going to enable to all the edges. I will click on save changes out here. So this is where dynamic edge to edge will work. So again, we'll do two validations. The first validation would be from the orchestrator. We'll do list path, we'll do VPN test, and you will see that you will have more path between the branches, and then we'll do the ping validation. So let me kind of stop these out here. I'm running multiple pings. Actually, I should be running ping in this use case because if you want a dynamic branch to branch tunnel to get established, you need to have some kind of an interesting traffic out here. So let me run ping between the client and the server out here. And when I say client server, where the AWS edge device is, and this is my home edge device where my laptop is like a client. So we are initiating a ping from here to the server out there.
So the difference between this and the last use case was that the traffic should go directly from the edge at your home to the edge in AWS, and it shouldn't touch the gateway in between. So we'll particularly see that in a trace route, won't have that middle hop to the gateway.
Correct. So we will initiate a trace route out there. So let me...
Got to make sure that we've got the connections up.
Correct. So we should have a trace route here, and we should see what's the next hop. So the next hop
do a
here,
-D on that trace route to not do the DNS lookup, and it'll respond rather quicker. -D.
-D.
Yeah.
And this is where you will see that my next hop this time is not going to be the gateway. It will be the next hop, which is the WAN IP of the AWS edge device. Let's first do a quick validation. Like I mentioned, we can do it from the orchestrator.
Tunnels are.
So you can see here in the list path, actually, it seems that the configuration has not been pushed yet. I should have waited 30 seconds in this case. Let me go back to monitor events and let's check out. And I think the configuration has just been pushed out. So now let me go back to remote diagnostics. Why we are waiting these 30 seconds is because of the keep alive messages between the orchestrator and the edge device out here.
And then there'll be a brief time to stand up that dynamic tunnel as well.
Yes, yeah. So you can see here, this is my LAN site, and then 52 IP address is on the other edge device, which is the AWS edge. And we can confirm that, and we are going to confirm it. But let me go back out here and do list path. You can see I have a connection to the gateway here, which are, those tunnels are always going to be on, but the data traffic is not going through that tunnel out here. Let's go back to the VPN test, and then I'm going to do a run out here. Ping is working out here. Trace route, you don't see the next hop as the VMware gateway out here. In the earlier use case, the next hop was the gateway.
There were 4 hops before we got to the destination, and now there's just 3.
Yes, here you can see it's directly reaching out, and I can just access the application also, in this case the VNC. So let me connect to it, and this is where I can access the server also in a dynamic branch to branch fashion. So you can see here it still shows me as passed. The latency has decreased here because now you are not doing multiple hops out here. So it's passed from my home edge to this AWS edge. Let me also check the list path, whether it has shown the other branch site or not. Let me quickly do that. So all the tools are out here, And when we execute the routing, I don't have to log into the CLI to do show IP route or show IP interface. Everything will be listed out here. So you can see here in the list path, you have gateways and the other branches where I can build up that dynamic tunnel out here. So you can see the New Zealand edge that's on your side of it, Alistair, and then the AWS edge where I can form that dynamic tunnel. So if I click on run out here, and this is where it will show a direct path.
The two different paths again.
Yeah, over Comcast cable and over the SAIL internet. So let me go back out here, go to monitor, go to edges. Let me click on the AWS edge device. And let me click on it here. Let's take the WAN IP on the side of it. You can see here it is 52.72.66.105. Our next hop, you can see here.
The trace route. And I think we didn't see a huge change in network latency because I imagine that there's actually a gateway in that same, or very close to that same AWS data center where your edge is running. But if edge and if it was two edges on data centers that weren't quite so adjacent to where the gateway is, you would see a much bigger change in the latency for that branch to branch versus through the hub.
Now let's move on to the last use case out here for this Cloud VPN. Again, we'll perform the same exercise. We'll trigger the blackout condition. What we are kind of validating out here is that your branch 1, which is my home edge, branch 2, which is that AWS edge, they form this dynamic SD-WAN overlay tunnel. When this blackout condition happens, if your traffic was going on WAN link 1, it should, in subsequent fashion, it should move on to the WAN link 2. It should not happen that your traffic goes back to the gateway and then it goes back to the other branch. Otherwise, that's the use case out here is with dynamic branch to branch, we are going to perform blackout condition, and we don't want to see that the hairpinning is happening through the gateway when the blackout condition happens. In the initial time when the dynamic tunnel is building up, yes, during that time, the initial traffic will go to the will get hairpinned to the gateway because we are waiting for this dynamic tunnel to get established. But once the dynamic tunnel get established, there is no way the traffic should either go to the gateway or to the hub, even when there is a blackout or a brownout condition. And that's the use case out here. And for that, what I'm going to do is I'm going to go back again to that live mode out there. So let me go back to my home edge device, transport tab, and we will put that in a live mode. So live monitoring, I'm going to enable the TCP UDP details, and I will uncheck TCP UDP for now because that ping is working. Let me check if the ping is on. Yes, the ping is on out here. So I'll only enable ICMP out here. So what we are validating is with the blackout condition, your traffic should not get hairpinned to either the gateway or the hub if the hub was enabled in this case. So in this case, we have branch to branch using gateway, but we have enabled dynamic branch to branch. So I'm again going to perform the same task where I'm going to pull out the cable. So let me go back, pull the cable, and be back here.
Did we want to wait and get some more? I suppose it's
no, the continuity will be there.
Okay.
So I pulled out the cable. You can see the Comcast cable with red. Our traffic has moved here. Let's do a trace route here. At the same time, we should have the same result. It should not that, and the traffic should be going through the gateway. So you can see here, even after the blackout condition, the traffic is still going on that dynamic overlay tunnel between these two branches. So that concludes the test case for this Cloud VPN out here. Let me quickly go back and turn on that link because we'll be needing it for the other use cases out here. So we have the Comcast cable up and running. You can see the traffic is back out here. That's conclude the test case for dynamic branch to branch in a blackout condition.
I have one question here.
Yes.
I noticed when you plugged it back in that it took a couple seconds before it, because you actually came back to your desk before it started to change over. Is that by design, or is that something that just happens?
So you mean when I plug back the cable in, you see this turning from red to green?
Well, that turning from red to green, but also the traffic I noticed stayed pretty dead until you came back to your desk, and then it started to liven up and switch over. Is there a point where it's waiting to make sure it's got steady traffic before it starts to register as data on here?
Yes, actually, because we continuously monitor both the circuits or whatever circuits are connected to the edge device. And then in subsequent fashion, we detect that the link is on, it can maintain that SLA, so it switches over. So it all depends on, and that's what we are going to talk in details when we do the application performance, because it might happen in the field that, the connection is going up and down more frequently, then that link is no longer good for that application traffic. So we also wait for a timer to make sure that the link can really kind of maintain the application SLA before we kind of move application traffic back to the preferred link or back to that Comcast link in this case out here.
So if it continues to bounce back and forth, turn off, turn on, turn off, turn on, it's not going to use it as a valid source until there's stability to it.
Correct.
Okay.
Understand, until it makes sure that link can maintain that SLA for that particular application out there. Otherwise, it will be bouncing back the user traffic. And what you have also noticed at the same time is our connection over Zoom is still intact. Zoom in this case is considered as a real-time traffic, and we'll be performing that test case back when we go back to the DMPO, which is our application performance use case. So now let's talk about the last two test cases where we talk about the traditional routing protocol. So you can see here, if you have a neighboring layer 3 device and your edge device, we can redistribute, let's say if you're running Ospf or BGP on these neighboring routers, we can redistribute the routes from underlay to SD-WAN overlay, and at the same time from SD-WAN overlay to underlay. So we have BGP support, we have Ospf at the same time, static routes using IP SLA. For this use case, what we are going to do is on my home edge, I have a router where I'm going to run Ospf, and I have subnets, multiple subnets which are defined, which are kind of configured on the other side of these traditional routers. So what we are going to see is once we form a neighbor relationship between our home edge device and that traditional router, which is on the underlay network, we will see those subnets being learned on the overlay, and we can try out redistribution and check out those use cases out here. This is just
this is all about interaction with an existing router configuration. That this is you don't have to rip and replace everything and have the VMware SD-WAN everywhere to get the benefit of this dynamic component.
Correct. You don't have to have multiple stack of devices for each network functions at the same time. And these are just 3 different type of routes from where you are learning those routes. So here we are focusing on the Ospf route out here. So let's try out the Ospf routing. So before we start this, check the global routing table, what we call it as OFC table, overlay flow control table out there. So here you will see that there are no routes which are being learned using any of the traditional routing protocol like Ospf. All these routes are being learned because they are directly connected. In my case, in my home edge on the LAN side, I have this 20.x subnet where this laptop is connected. So that's why you see that route as connected out here. So let's go back to profile. And what we are doing out here is, again, let me quickly talk through this is my home edge device. This is where my laptop is, which is connected to 192.168.20.x. I also have to one of the interfaces out here, let's say Gigi1 is where this router is connected, where I'm running OSPF. And there are multiple subnets defined here, which are 192.168, 100.x, 101.x, 102.x, and so on. So we want to see, once we enable OSPF on this home edge device, we should be able to form an OSPF neighbor relationship out here. That's number one. Second thing is, this is the internet. If you remember, the AWS edge is out here. So when I go to the local routing table of this AWS edge device, I should be able to see these subnets out here in the routing table. And at the same time, I should be able to, from this 10.x Windows machine, I should be able to reach to these subnets, because now I have connectivity. What it means is underlay routes are now getting redistributed onto the SD-WAN overlay. So this is kind of before. You can see the overlay flow control. So now let me go back to the profile here, and we will enable the OSPF. So on my traditional router, on my router device, the OSPF is enabled. Simple clicks here, OSPF is enabled. I will use area 1 out here. I will click on Save Changes. We'll wait for 30 seconds. We can monitor the Events tab, and we'll see that the OSPF neighbor relationship getting formed between the edge device and that traditional router. So what we are going to see is between this router and my home edge device, OSPF getting established. So let's wait for the 30-second to happen out here. And I think this is where it was showing that the link was down, and now it has come up. So let's go back here to events, wait for 30 seconds. You can, let's see the
configuration applied.
Yeah, configuration applied to the AWS edge device. It should apply to my home edge device also. And we'll see some OSPF events logging happening out here. You can see here, there is some OSPF events which has happened on my home edge device. You can see here a neighbor relationship is formed between the home edge device and that router out here. Now let me go back to the configure page, overlay flow control, and I don't have to refresh, but you can see out here that it has got those subnets 100.x, 101.x. It has learned using OSPF routes. You can see here 1, 2, 3. There is 5 out there. I think there should be 4 also. I have to check why 4 is not here, but this is what you see. What you're seeing out here is from the underlay, we are redistributing it to overlay. That's what the use case was, where it shows the routing supports on the LAN side, on the WAN side. So you could be running OSPF on the LAN side. On the WAN side, you could be running BGP, or either way. Nobody runs OSPF on the WAN side. So, but what I mean to say is that traditional routing protocol support is out there. And what we also need to validate this. So let me go back. Let me VNC to this edge device out here. Actually, before that, let me show from this AWS edge device that the local routing table of this edge device, that it can see these subnets quickly. So let me go to test and troubleshoot, remote diagnostics. Again, we don't have a CLI. You don't have to log into multiple devices. Go to the CLI, do show IP route interface, show IP OSPF. We are just going to use this edge device out here, this orchestrator. I'm on the AWS, remember. So over the overlay, using the Cloud VPN, it's learning these routes. You can see here 105, 103, 102, 101, all these, it is learning using the Cloud VPN. And then just for validation, I can log on to this VNC server out here, and I can ping these subnets out there. So I'm able to reach. What we have done is validated is that these subnets, which are learned using OSPF from the underlay, they were redistributed onto the overlay, and then the branch 2, in this case, the AWS edge device is able to reach those subnets. And then let's say if you have 100 of these routes being learned from the underlay, like in this case, the Ospf routes, and if you really want to filter it out, you have that filter option using simple control out here. So I can go to the edge device out here. I can do it from the interface level out here. So let me go back here to the edge device. This is to my home edge device. And I can go to that interface level out here. You can see OSPF is enabled. That's one of the settings you need to do it. So I can go here, toggle, and then you can see why 104 subnet was not getting learned out, because I filtered it out. You can see the ignore button out here. So I can also select one more subnet out here, which is 102.2/32, and I can say instead of learn, just ignore it. By default, the action is learn, so all the underlay routes get redistributed to overlay. So what I'm doing here is 102 and 104. Actually, 104 we can remove it. I can say learn because we were not seeing it earlier, or I can just kind of remove it also. So let's remove it. 102 subnet should not be seen out there. So let me click on update. Again, we'll wait for 30 seconds to happen, and then we can check out the overlay flow control table, which is called the global routing table, and we should not see the 102 subnet out there. So this subnet,
we should get the 104 subnet now.
Yeah, and then we should see the 104 subnet out there. And this shows that who's the owner for that route. So in this case, the owner is my home edge device, which is the owner for that subnet, which is, so if any other edge device wants to reach this 100.x or 101 subnet, they will send it to this owner out there. So let's refresh. We are waiting for 30 seconds. And you can
102 is gone.
Yeah, 104 is back and 102 is gone. So we have seen both the use cases out here for the routing protocol support, where we did the OSPF routing and then route filtering. Imagine if you have 100 routes, you want to filter out routes, so you can do that using the overlay flow control global routing table. Again, you can run routing on the LAN side, on the WAN side. We started off with the Cloud VPN, where you can have multiple topologies supported, hub and spoke, branch to branch using gateway or hub, where you can hairpin the traffic to the hub side, or you could also have dynamic branch to branch, everything with just that one click which is happening. By default, the edge device will build up the overlay tunnel to the gateways. That's the control plane traffic. Once you change the role of the edge device to the hub, then you can see that static overlay tunnel, which is kind of end-to-end. And then we just saw the routing protocol support. We executed for the OSPF, but we have support for the static BGP. A lot of route maps which are configured on the BGP. On a traditional device here, with simple clicks, you can have filtering enabled in those route maps. So 50 codes or 50 lines of the configuration, routing protocol configuration, can be kind of just changed with a simple click out there. I think this is what we have for this episode. Alistair, back to you.
Great. Well, thank you, Rohan. That was a lot of options about how you establish connectivity between the different elements of your VMware SD-WAN solution. So thanks for all of that hands-on time and digging into all of the failure modes as well. Stay with us as we carry on learning about the VMware SD-WAN solution. So tune in again next week, and we'll have we're doing dynamic path optimization next time, aren't we? Cool. So stay tuned. More great VMware SD-WAN solution coverage coming. And thanks, Jeffrey, for asking some good questions, making us look good. And thank you, Kelsey, for making it all happen.